Okay, so now we're looking at an example they're giving us on page 536 of the student text. It says you can calculate the correlation coefficient. Remember, the correlation coefficient, that's this R value right here, of a data set using this formula. Now, don't get nervous about this formula with all this combobulated bunch of symbols and equations. It says right here, most of the pieces of this formula look familiar. I think we used them in the formula for standard deviation. Now, if some of you are new, just jumping in this semester, and maybe didn't do standard deviation, that's all right. We can still do this. We do it one piece at a time, one little piece at a time, and they demonstrate it. So if we go over it, we look at it right here. It says, let's determine the correlation coefficient. Remember, the correlation coefficient is the letter R. That's the correlation coefficient. So when they're talking about the correlation coefficient, they're talking about the letter R. Let's determine the correlation coefficient of this data set using the formula. Now, the data set they give us is right here. So we're looking at a data set. That's the data set. The point -3, -3, 1, 2, and 3, 4. So we could plot those on a graph. But for what we need to do to obtain R, we don't really need to do it at this point. Something they point out over here, it says, keep in mind that the notation where it has the sigma here for sum just tells you that you'll be determining the sum of all the data values. And notice right here, they've got that sum. And it says, look at the numerator of the formula first. So if we go back and look at the numerator of the formula, right there on top, see there's a division, like a fraction, division bar right there. So this here's the denominator, and up here's your numerator. And they're saying, look at the numerator of the formula first. So we're going to circle the numerator right here. That's the numerator. And we're just going to go ahead and we're just going to draw arrows. So this is what we're going to do first. We're going to look at this and only focus on that. We're going to solve to get this, and then we can plug it back up here as a number. And then we'll focus on the bottom. We'll focus on each one, get a number for each, and then plug the numbers in. And it just turns into a fraction problem. It's pretty simple. So let's go ahead and start working on it. Now they say here, determine the mean of the x values and the mean of the y values. Okay, so if you forgot what that represents or what it means, your mean is your average. This little a right here, that stands for average. And they use a symbol for this. The symbol for mean, the symbol for average, well, they want it for the x value and the y values. The x values and y values. So there's two ways we can do it. And they do it. They do it right here. They got the bar with the x. That's the average of x. So you would average all these x values. So right here, x and y, x and y, x and y. Each coordinate point has an x and y. So you average all of the x values, and then you put that value right here. Then you take the average of all the y values, and you take that value and put it right here. So, average, it could be a bar with an x. It could also be, symbolically, it could also be a bar with a y. And notice what they have right here. They have a bar with an x, and that's 1/3. And they have a bar with a y, and that's 1. How did they get those? Well, if we do this real quick, we'll go x. This is the first point, so I'm going to put sub 1. This is the second point, so I'm going to put, oh no, sorry. This is still the first point, so x sub 1, y sub 1. Right here, this is the second point, the second data point. So we'll go x sub 2, y sub 2, because that's the second data point. And then right here we'll go x sub 3 and y sub 3, because this is the third data point. So now, what we do is we take all the x values, x sub 1, x sub 2, and x sub 3, and we could do this. We could say bar over x, or the mean of x, that's equal to all the x values. We have 3 x values. So we've got, for the first one, we got -3 plus, and then the second one is 1, so 1, and then the third one is 3 plus 3. And because we have 3 x values, we've got to divide it by 3. That's how you take the average. Well, this -3 and that +3, those two are going to cancel each other. So all you're left with is 1 over 3. And notice, we've got 1/3, they've got 1/3. Similarly, you do the same thing for y. We put a bar over y, and let's see, right here, we're going to go, for the first y value, we've got -3, and we want to add the next y value, which is 2. And then for y sub 3, the third y value, we've got 4, so we add that 4. And then let's see, how many values do we have? 1, 2, 3. So we got to divide it by 3. And what ends up happening is we get 2 plus 4 is 6. 6 minus this 3, the -3, that's going to be a 3. So you're going to end up with 3 over 3. Well, 3 over 3, that equals 1. And look what they got. The mean, or the average of y, is 1. So we have the same values they got. Our average of x is 1/3. Their average of x is 1/3. Their average of y is 1. Our average of y is 1. Okay, so we just kind of hold on to those values. Let's take a look at the next page. Now they say, determine the difference between each data value and the mean, the average, for both the x-coordinates and the y-coordinates. Okay, so what they want you to do now is they want you to use those coordinates. Now, I'm going to go ahead and write the coordinates up here, just so we have them handy. So we've got -3, comma, -3. That was our x sub 1, y sub 1. That was our first coordinate. We had 1, comma, 2, and that was x sub 2, y sub 2. That was our second coordinate. And then we had 3, comma, 4. And that was x sub 3, y sub 3, because that's our third coordinate. And basically, I just got those off the previous page where we finished up. See the 3 data points right there? I just pulled them off and I just wrote them right there. That's all I did, just so I could make it easy so I don't have to flip back and forth between the pages. Now we take the average. See, they got this equation here. If you notice what they have right here for this equation, it shows each x value right here, we're going to subtract the average from it. So this x value, we sub it in right here for this, and then we take our average, which is 1/3, and we sub it in right there, and we subtract. But we got to do it for this x value, we got to do it for that x value, and that x value. Then we got to do it all over again for the y values. So we got to do it for this y value here, and subtract the y average for this y value and this y value. So that's why you see it 3 times written, because they take the average for x, the mean of x, mean is average, and it's 1/3. Remember, we calculated that. And our x value here, well, the first coordinate point is -3, so you got -3 right there. So that's this one right there, that -3. And then what they do is they subtract those, and you could do it on a graphing calculator or on your computer. You can go ahead and subtract it, but you want to have it in fraction format, and you'll get -10/3. And we have to save this here because we're going to use this. This is what we want right here. So we do it for this coordinate point, then we got to do it for this one. So we bring down our x value, we put it right there, we subtract the mean, then we get 2/3, and we got to save that, and then we take our 3, this x coordinate point, and I'm going to go all the way around right there. And then we get this value right there. That's what we want. And we hang on to these. And the way I brought the x coordinates over here, well, now you got to do it for the y coordinates. Now, I'm not going to draw any more arrows. If I do that, I might make it messy. But I think you have the idea. With what I did over here, what you should do on your paper as practice is you should draw the arrows for this one, if you feel comfortable. Or if you know what you're doing, you should. It's not that hard. So right here, we're taking it step by step. This is the mean of y, or the average of y. We get it from the previous page. If we look at the previous page, the average of y was 1. That's what they got. And I showed you how you calculate it. The average of y, we took all the coordinate point data we needed, and we got 1. So we sub in for the average of y, or the mean of y. We got our 1 for each of those. And then right here, -3, we got a -3. We subtract those, and we got -4. And then we do the next one, which is 2. And right here, we got a 2. And then we take our 1. That's our average of y, our mean of y. And when we subtract those, we get 1. And then the last one right here, 4. And there's 4 right there. And then our average of y is 1. That one doesn't change because we're just subbing in the average of y. We have to do it for every coordinate point. That's what changes, the coordinate points. And when we subtract those, you get 3. Okay. So now, here's what we do. This here, it says the sum. The sum means to add. So what we have to do is we've got to do some multiplication and some adding. It says here, determine the product of the differences in each pair. Then determine the sum of those products. This is your numerator. Okay, so let's make it real simple. What we're going to do is we're going to take these two, we're going to multiply them. And we're going to do that for each pair that we've got. So we'll take these two, we'll multiply them, and then we'll take these two right here, and we're going to multiply those. So here's what we do. We got -10/3. They wrote it right there. We're going to multiply it by the -4. They got it right there. When they multiply these two right here, they get this number, 40/3. Let me draw the arrows, so this way you at least see with the first one, this is how they're doing it. And then for the others, you should be able to kind of catch on to the pattern. So we get those numbers, we multiply and we get this number. Now we're going to hang on to this number now. We do the same thing again. See these two? First let's do the 2/3. 2/3 is right here. And then we multiply it by the y value, which is that 1. The difference of the y values. And then when we multiply those two, you get this 2/3. We want to hang on to that. Then we got 8/3 and 3. Your 8/3 is right here. And then this 3, well, that's this 3 right here. So now, 8/3 times 3, that's going to be 8. Now, what they want us to do is they want us to add these. Because remember, the sigma means sum, and sum means add. Should we write that right here? Maybe that helps. It just helps. Sigma means sum, and sum means add. And guess what we're doing right here? We're adding them. Look, the 40/3, and then we add 2/3 right there, and then we add 8, and then they get 22 right here. That 22 right there is our numerator. So we could say that 22 is our numerator. And that's what we got to hang on to. We're going to come back to it. But for now, we're just going to leave it. Over here, we got to work on that denominator. Now, if we go back to the previous page, the denominator here, notice it's got a radical, it's got a sigma for sum, and it's got the difference of the x values there, but it's also got a square. And inside this radical, they do the same thing for the y values, and there's a square there. So it's pretty much what we did already. We're just adding another step. We got the radical on the outside, and we got the square right here on the inside. So it's actually not that bad. And we've got part of it solved already, because for each of the coordinate points, we did this for the x's. So really, we can borrow from up top. We can take the negative 10/3, because we already did it right here up top. See up here? We got that inside piece. The x sub I minus average of x, or mean of x. And that's what we need just right here inside, just inside of those parentheses. So that's what we're taking. And that portion inside the parentheses, that's what this negative 10/3 is. So that's how they get that negative 10/3 right there. And then they square it. And then they do the next one, 2/3, and they square it. And then they do the 8/3, and they square it. And that's how they're getting these values here. And then all these values, well, remember, right here, we've got a sigma, and sigma means sum, and sum means to add. So you add all these here, and you get this number. So we got to hang on to those. Got to hang on to this one here. Right here, we do the same thing again. The y values, well, right here inside the parentheses, the difference of the y values, we did that. We did that way up here, so we can borrow that. We can take that, we bring it down here, put it in the parentheses. We got a -4, we square it, and we get 16. Hang on to that one. We got the +1, so +1 squared is 1. Hang on to that. Then we got a 3. 3 squared is 9. And then remember, there's a sigma here, and it's saying all these parenthesis values, after you square them, we want you to add them up. So we add these values, and you get 26. So now that we got 26 and 56/3, all we got to do is substitute them. Oh, let me move that up a little bit. Right here, 56/3 and 26. So now these values, really what they do is they go inside here. So this value goes right there. And all this right here, really, it's just that 26 is that. All this madness is that 26. All this madness is 56/3. So you put it inside, and when you put it inside, it just turns into this radical with a fraction inside. You plug it in the calculator, and you get this number here. This number is an approximation. Notice how they don't put the equals sign? Now we're just going to do a little squiggly line. That's not the answer. We're just going to save it. Same thing again. Radical of 26 is this number. We just need something we can put in the calculator. So now, in the formula, originally, let's take a look at it again. You notice these two were multiplying. We're multiplying all this in the denominator by this in the denominator. So, these two values here, we're multiplying them. Move that up. We're multiplying these two. So if we're multiplying these two, really, we know this goes right here and this one goes right there. So you just end up multiplying the two values, and that's what they do right here. And that's how they get this number right here. So our denominator is this value right there. Okay, hang in there, we're almost there now. So with our two values, what they do now is they tell us to put them together, determine the correlation coefficient of the data set. So what we do is we got to make a fraction. Just wanted to give you a moment there, see if you know what to do. Okay, so what we're going to do is, let's go back to that original formula. Let's go ahead and write it out. We're going to go back to this formula right here. This is on page 536. So let's go ahead and write it out. We'll go R equals, and then we'll do our sigma. Our N, that stands for how many data points. And I'm having a hard time seeing there. Okay, and then I is 1. And then right here, our first data point. And we're going to subtract the average of the x values and multiply it by the difference of the y values. Okay, and that's our numerator. Our denominator, let's go ahead and get familiar with writing this out. N, that's how many points we have, how many data coordinate points we have. And I is 1, so we want to start with the first point. And we got x sub I minus the average of x. And we're going to square it. And then we're going to radical it. And we're going to multiply all of that by all of this right here. All this madness. It's not really madness. This is all stuff we need to know. This is how our world functions. This is how people make decisions for us. We should be in control of our decisions. Gotta know this stuff. This is where the big money is. Okay, so we got that equation down. Now, we figured out the numerator. If we go back on page... where was it? Right here. 537. Page 537. I should have done a squiggly box on that one. The numerator was 22. So all this on top, I'm going to just put an equals sign. So this portion right here on top was 22. That's what it came out to be. And then our denominator right here was 22.02768. That's what they got there. So we're going to do that. 22.02768. Now, just by looking at that, you could tell that's pretty close to 1, but it's not going to be 1. You know, 22 is smaller than this number. This number's got a little fraction on the bottom, so that's what makes it bigger. So we could say it's approximately, and if you put it in a calculator, what you should get is 0.9987. And we could write a real simple statement with that. The correlation, we want to get used to writing sentences explaining what it is that they want. It says determine the correlation coefficient of the data set. So I can turn this into an answer. I could say the correlation coefficient of the data set. The correlation coefficient of the data set That's what you want to do. Take the questions, turn them into the answer. The correlation coefficient of the data set is, and we'll say R is approximately 0.9987, period. And then they want us to interpret the correlation coefficient of the data set. Interpret, what does it mean? Well, let's see here. We could say a correlation coefficient oh, there's supposed to be an I there. Oops. Correlation coefficient of the data set that is close to 1.0 has a strong correlation. And we could say the correlation coefficient of R approximately 0.9987, we could say it has a positive association. Okay, so something we should add right here is that it's linear because it has a strong correlation. But that's alright. I think we went over that already. So now what I want you to do is I want you to go ahead and stop, and I want you to do numbers 7 through 12 in the skills practice. Those are on pages 496 through 501. Then I want you to come back and look at the rest of the videos.